Hi everyone in rubber industry. I'm Yuri from Shenzhen Cam. We have seen this pattern many times. The lab compression heat buildup looks unacceptable. Maybe just a 20-degree temperature rise, but once the part goes on the road or into durability rig, halfway through the cycle, the stiffness drops and the dimension shift. The issue doesn't show up on standard spec sheets. Meeting routine physical specification doesn't guarantee dynamic performance. The core problem is cross-link network stability under prolonged high temperature. In NR compound, one internal heat from flexing exceeds a certain threshold. Polysulfide bonds start breaking and rearranging. On the rheometer curve, that's torque drop. On the part, that is a loss of modular support. This degradation is usually irreversible. So why are NR carbon black systems so sensitive to heat build-up? It starts at the micro interface. Carbon black particles rub and agglomerate under dynamic strain. If dispersion is poor or interfacial bonding is weak, hysteresis goes up. Adjusting sulfur or anti-dioxide dosage alone won't fix this. You have to intervene at the mixing stage, especially at the filler-rubber interaction. So the approach is fairly straightforward, using surface-active additive during NR mixing to improve carbon black dispersion while creating a buffer layer between chain ends and filler. The direct outcome, lower hysteresis loss, 60-degree tended data around the 0.08 level, and a tighter dynamic stiffness ratio. That translates to better damping balance and lower heat generation in surface. For anyone making formulation decisions, the biggest concern with a new additive is disrupting curve or sacrificing tensile strength. The feedback so far shows tensile retention is unchanged and reversion is delayed. Think of it as pre-reinforcement for dynamic properties in NR compounds. Low dosage added in first pass. Reducing uncertainty matters more than just cutting cost. We are aligned on that. So if you want to get a sample, just contact me at any time.